Alright, our next lesson is a continuation of section 9.2. Today we're going to look at trig functions, some that you've seen before, some that might be a little bit new, or at least newer, and we'll continue to use the unit circle that we talked about yesterday. Make sure you have that blue sheet out. Make sure that you have your unit circle out so that you can refer to that as you need to. We're going to look at the 6 trigonometric functions. Although this to begin will be a review for you. You can slow it down as you need to when we start getting to the ideas that are maybe a little newer, or at least not as well ingrained into your mind. So your 3 basic trig functions: sine, cosine, and tangent. Remember that opposite, adjacent, hypotenuse, those are all positions or sides of the right triangle. Cosecant now. Cosecant is the reciprocal of sine. Now it's not the inverse of sine. It's the reciprocal. So on your calculator, it's 1 divided by what you had for sine. Or there's a key over on the left-hand side of your calculator that says x to the -1 power. That's the reciprocal key. All right. A lot of people mess up cosecant and secant. The only thing I have for you right now is just try to remember that the C and S are opposites, meaning cosecant goes with sine, secant goes with cosine. Alright? And obviously cotangent goes with tangent. So these are just reciprocals. You're thinking about right now, even I'll talk about this later too. Think about what numbers are going to be able to go in for these values. What kind of angles have cosecant, secant, and cotangents? That's domain and range problems again. We'll talk about that later on. If you remember yesterday, we talked about how on the unit circle you've got x and y and r, and how those 3 sides create the right triangle that is in the unit circle. So again, we can apply this idea to the trig functions with the angle. So whatever your y coordinate is divided by the radius, that's going to be your sine value for a particular theta. The cosine is just going to be your x coordinate divided by the radius. And again, you can find these on your blue sheet. Here's a little proof of why tangent is y over x. If you take the sine of an angle and divide it by the cosine, and really that's what tangent is. Tangent is sine divided by cosine. Multiply by the reciprocal, you'll notice that the r's drop out, and there's your y over x. So if you take your y coordinate divided by your x coordinate, that will be the tangent of theta. So let's apply this idea now to the 3 new trig functions: cosecant, secant, and cotangent. Remember, those are reciprocals of these first 3, so it shouldn't be too hard for you to figure out what those are going to look like. So instead of having y over r for sine, we'll have r over y. Instead of having x over r for cosine, we'll have r over x for secant. And instead of having y over x for tangent, we'll have x over y. So again, if you have your blue sheet out and you have a particular theta on there, coming up with these values shouldn't be very difficult. You can just look at the blue sheet and figure that out. Now what I'd like you to think about again is, though, are there values, are there places on your unit circle where these functions don't exist? Why wouldn't they exist? Because your x or your y is equal to 0. Be thinking about where those values are. Where are those functions undefined at? Be a question I ask you to talk about later on in the video. So let's get a little practice with this information now. I'd like you to find, and we'll do it together, but if you'd like to pause and try some of this on your own, I'd like you to find the exact, and that's important right now, the exact values for all 6 trig functions for a couple different thetas right now. We'll look at 2 or 3 of these examples right now. The first one is theta equals 3 pi over 2. So figure out where 3 pi over 2 is on your unit circle. Should be able to find it. If you have a hard time, it's straight down from the origin, so it's along the y-axis. Look at the coordinates of that unit circle. Coordinates of that point is 0, -1. Using that x and that y, and the fact that the radius of the circle is also 1, you should be able to fill in those 6 values. Alright, here we go. See if you have these right. The sine of theta is going to be, remember, your y coordinate, so -1 divided by your radius, which is a +1. Cosine is going to be your x coordinate, which is 0, divided by your radius of 1, makes it 0. And then your tangent is going to be your y, which is -1, divided by your x, which is 0, and so this is undefined. So 3 pi over 2, or 270 degrees, does not have a tangent. Does not have a tangent. And you'll find that anything along that y-axis does not. Your reciprocal values, just flipping those upside down, we see here that the cosecant now is undefined, but the cotangent now is 0, because if we take the reciprocal of -1 over 0, you get 0 for an answer. So hopefully that doesn't make too much confusion for you. Let's try another one. Now we're going to go theta is 13 pi over 6. 13 pi over 6. Now the first thought you might have is, hey, 13 pi over 6 isn't on my unit circle. But 13 pi over 6 is coterminal with the angle pi over 6. Remember, coterminal means that its initial and its terminal sides lie in the same spot. So an angle that is 13 pi over 6 is going to have the same trig values as the angle whose measure is pi over 6, because it forms the same triangle. Think about that for a second. I'll say it one more time. It forms the same triangle, has the same initial and terminal sides. So its x, y, and r are all exactly the same. So again, what are those values? If you want to pause and figure that out first, go ahead. For sine, the y value is 1/2 divided by the hypotenuse, which is 1. So sine of that angle is 1/2. Remember, these are exact values again. Cosine is radical 3 over 2 over 1. So radical 3 over 2 is our cosine value. Remember, and really, if you're on the unit circle, your sine and your cosine are just your y and your x values, respectively. Now tangent, a little bit tougher. You got a complex fraction to look at there. We're going to multiply that by the reciprocal. 2's cancel out, and now you have 1 over radical 3. Perhaps last year in Algebra 2 you were taught that you can't have a radical on the bottom, so we're rationalizing the denominator by multiplying it by itself on the top and the bottom. Radical 3 times radical 3 is radical 9, which is 3, and so that's radical 3 over 3. Again, here are your reciprocal values. 1 over 2, the reciprocal of that is 2 over 1. Radical 3 over 2 again has to be rationalized now, so you get 2 radical 3 over 3. And the cotangent, when you work it all out, is going to end up being radical 3. You might see it if you look back at the original problem. You might see where that answer comes a little bit quicker than going through all this work. But if you don't, you can go through all the work and cancel out your 3's, and there's your answer. It's a little tougher just because of the radical part of it. Here, one more example. Maybe it's easy, maybe it's harder, depending on your visual understanding of angles and right triangles and things like that. Suppose we want to find that theta. We want to find its trig values. Now, hopefully you had a really good geometry teacher who taught you how to do all of this. We'll pretend that you did. And the first thing you're probably going to do in this problem is, find the hypotenuse. So we use a little Pythagorean theorem there. 3 squared plus 4 squared. Maybe you recognize that that's a Pythagorean triple. and your radius is going to be 5. Once you have that, now you have your 3 things you need. You got your opposite, you got your adjacent, you got your hypotenuse. Filling in those numbers, leaving them in that exact form. There you go. There's your reciprocal trig values, and those are your 6 answers. Hey, if this is still a little bit fuzzy for you, you can try these examples and come to class tomorrow with these answers. If you want to verify that you're doing them correctly, you can try theta equals pi, theta equals negative pi over 4. Be thinking about the whole coterminal idea again, maybe there, or not, you don't have to. And theta equals 120 degrees. Does it change at all if we're in degrees? We talked about radians the whole time, but how is degrees going to be any different, if at all? So really for the rest of this video, we're just going to look at a lot of odds and ends right now. Before we do that though, pretty important, make sure that when you are doing these problems, know what the sign, when I'm talking about the sign, I'm talking about positive or negative, make sure you know what that's going to look like as you're answering these problems. Remember, your sign is going to be different depending on which quadrant your theta is in. And so if you've forgotten this, here's a little review. You might want to jot this down somewhere so you can refer to it. It's also on I believe in your packet, in your blue sheets. You might get something like this as well. And remember that both the x and the y are positive in the first quadrant. The x is negative in the second quadrant. Both of them are negative in the third quadrant. And the y is negative in the fourth. So what's this have to do with your trig values? Well, remember, think about what goes into creating sine, cosine, tangent, cosecant, secant, and cotangent. Since you're using the x and the y's for these different functions, having a negative in a particular quadrant is going to make that function negative. Having a couple negatives might make it positive. So again, refer to that. I think it's a third or fourth sheet in your blue sheets. Should be a little chart that helps remember. Maybe it's a little bit further along. It says quadrant information. It's a really good summary of where each of those functions are positive and negative at. Alright, so as I was saying, the rest of this video, I apologize for being lengthy, but there's just a lot of things to kind of talk about and go through. But the rest of this is just some odds and ends that we kind of tie up here over these last few minutes. So as I kind of introduced earlier, or gave you a hint earlier, I want you to think about the domain and the range for all 6 functions. What numbers can you plug in? What numbers are you going to get out? I'll start you off a little bit. I'll have you think about the sign, which isn't too hard. But then I'd like you to pause the video, to take some time to think about the other ones. So for the domain, what values can you plug in, what thetas can you plug in and get a sign for? Right? In this case, it's all reals. Every single number, every single measurement gives you a sign value. You're never going to get an error or an undefined when you come out of that. And why is that? Because you're dividing by the hypotenuse. And there's always a hypotenuse, there's always a radius of the unit circle. But the range, what will the range be? The range will be -1 to +1, including those. Again, why is that? Because of the hypotenuse. You're taking the side of the right triangle, dividing it by the hypotenuse, which we know has to be longer than that side, or at least as long if it's on the axis. And so you're always going to get an answer that is a fraction. Again, on the axes, you'll get an answer that's either +1 or -1, or 0 at times. But you're never going to get a number bigger than or smaller than those 1s and -1s. Now, keep that in mind. I'd like you to think about what the range and the domain are for the other 5. So, push pause if you are looking for a challenge here. Try that. Be a good thing for us to talk about tomorrow. Especially if you're struggling with the idea. Hey, second kind of thing to discuss here. the idea that these functions, the sine curve, the sine values, the cosine values, these are what we call periodic functions. Some people refer to them as cyclical. It just means that they repeat themselves. If you remember, I mentioned earlier in the video that theta of pi over 6 has the exact same triangle, so the exact same coordinates as theta of 13 pi over 6. They're exactly 2 pi away from each other. And so the triangle you create is exactly the same, so their trig functions are all exactly the same. I show you that here, maybe with a little bit more formality. If you break that up and you take the sine of each of those individual angles, we know that the sine of pi over 6, found it earlier, was 1/2. The sine of 2 pi is exactly the same as the sine of 0, which is 0 over 1, which is 0. So add those together and you see that the sine of 13 pi over 6 is indeed the same as the sine of pi over 6. So if given an angle that's not part of your unit circle, find the angle that it is coterminal with in the unit circle and solve those. So if you need a little practice with that, which I would recommend that you do, try finding it for theta equals, how about 8 pi over 3. Find all 6 there. Be ready to talk about that tomorrow if you've got questions. So I've given you a couple homework problems, I guess, if you will, to work on for me. Next idea to look at is odd and even functions. Think back to our algebra review chapter. Remember, even functions are those that when you plug in x or the opposite of x, you get the same result. Odd functions are those that when you plug in x and its opposite, you get an opposite result. So remember, the opposite of f of x is the result when you plug in the opposite. So for these 6 functions, which ones are even and which ones are odd? How could you go about figuring that out? How can you figure out if the sine function is an even function or an odd function? Well, the odds are sine, cosecant. Should make sense that if sine is cosecant because they're reciprocals of each other. Tangent and cotangent. Again, that should make sense why those two go together. The 2 even functions then are cosine and secant. Again, how can you figure that out? You can do it algebraically. You could plug in theta equals pi over 4, and you could plug in theta equals negative pi over 4. Now if they're an even function, what should happen? Well, the sine, or in this case the cosine of those 2 angles will be exactly the same. The sine of those 2 angles should be opposites of each other. You could also take a look at their graphs. Remember from that last chapter, odd functions are going to be symmetric with respect to the origin, or the line y equals x. Even functions are going to be symmetric with respect to the y-axis. Alright, last idea. Bring this to a close. You know, and it's no surprise that we're going to use our calculator to find a lot of this. But remember, when we use our calculator, we're finding approximate answers. Not very helpful for exact answers, but it is really useful if we just need an approximate answer, especially if we're going to use it in an application problem. Find the measure of some length or some angle. So we are going to use our calculator. So just make sure we know how to do that, especially with some of these trig functions that we don't use as much. But before we get into that, most important thing, and I can't emphasize this enough to you because this messes people up every year on quizzes and tests, you must know which mode your calculator is in. It's so frustrating to have your calculator be in degree mode and you're working with radians, or vice versa. Remember, you can always check that under your mode menu up there towards the top left of your calculator. You scroll down a couple on that, you'll see degree and radian there. make sure you're in the mode that you want to be in. So I'll throw a couple trig values down here. If you would please, once you see them, push pause, calculate all those, use your calculator for each of them, and then you can unpause the video and compare answers with me. Thinking about how you're going to do some of those reciprocal functions. You notice I'm also putting some over here. Now you'll see degrees on those, so in case you didn't know, if you don't see a degree symbol, you must assume that it is talking about radians. Alright, so push pause and do your work. Alright, here are those answers. Hopefully you're getting the same thing I'm getting. It's customary that you're going to go out about 4 decimal places when you're doing trig functions. So on your calculator, for cosecant of 53, you can just do the sine of 53, and then you can hit that reciprocal key. Remember, that's just over there on the left. It's x negative 1, and you should get this answer. Again, you shouldn't have to write it down or anything like that. You should be able to leave it right in your calculator and do that work. Here you get a negative value for your tangent, because remember 120 degrees is up there in the second quadrant, and since your x value is negative, y divided by x is going to give you a negative tangent for that. Again, we're using reciprocal functions here. So the cosine of 45 degrees is 0.7071. Reciprocal, that's going to be 1.414. Now we go over to radians. Remember, first thing, real important, make sure that you are in radian mode. Once you do that, it's just as easy as what we did before. Cosecant of pi over 3 is going to be 1.732. If we were doing exact values, I'm sorry, it's 1.1547. My bad on that. Remember, on this one, it's a sine of 2 radians, not 2 pi radians. So make sure you put that in correctly. Don't assume that it's always in pi. And the last one, cosine of pi is 0, remember. Cosine at 180 degrees is 0, because you're, I'm sorry, my mistake. That's negative 1, and so then the reciprocal of that is still negative 1. If you want to get a little jump on your homework problems for tomorrow, first of all, make sure you do the problems that I indicated to you during this video. I think they're very helpful to you. They'll reinforce whether or not you understand what I'm talking to you about. It's good talking points to start class tomorrow if you do struggle on those. So if you haven't done those problems, you really have no idea if you need to ask questions about them or not. In addition, if you want to get a head start on some of the problems I'm going to ask you in class tomorrow, those problems are on page number 580, and we're going to look at problems 27 through, let's see here, 27 through 58, and if you want to do all those, you can. Alright, I'll talk to you next time. Bye.